Hello everyone, welcome to Quantum Guruji. So today in this video, I will show you how to make pictures for publication purpose. Okay. So whenever we are doing a theoretical calculation is important, and representation is more important than the calculation and other thing, right? So suppose you want to have a pictures pertaining to your molecule. What are the good perspective and the quality that is important here? Okay. Suppose I am looking for the picture for this molecule here. First, I will close all of the windows that is open here. Fine. So as you can see, this is a transition state. Okay. So this is the transition state. What is happening here is in this transition state, this allyl group is combined with this metal and this like this silicon here. In the early, if you see the initial structure, yeah, that's fine structure. Okay, just go to the results and see the negative frequency. If you see what is happening here, this hydrogen is shifting from the metal to the allyl group, and it is leaving as a allyl, right? So that is your transition state. Suppose I want to have a picture of this particular step. What I will do is, first of all, there is a bond between this, right? If you see the distance is 2.63, it is Gaussian is not showing bond here because Gauss, the algorithm of Gaussian depends on the distance of atoms, and sometimes the bond is not shown. So you can go to this menu here. If you see, click here, and then you make a manual bond between these atoms because there is a bond here. If you are not doing this, the structure that you are providing will be misleading, and sometimes it is not easy to identify. Now what is happening, this is the transition state, right? So the transition state, what is happening, this allyl group is leaving and this hydrogen is attaching to this allyl group. So what is happening here, it is connected and this hydrogen is leaving, so it is shared between these two atoms. So right now it is connected and it is trying to go away after taking this hydrogen. So I will put this dotted bond, which is a like weak interaction, and palladium most in the +2 oxidation state, it will be in the square planar form, right? So that a square planar form like it has to be shown. Here it is in the +2 oxidation state for coordination, so it will be in so called in the square planar, while this is kind of octahedral transition state, right? So that also has to be shown in the picture. If suppose I can put this picture in any way, but I have to sort for information here. First, this palladium as a square planar, this palladium as a octahedral, and this allyl group taking this proton and going away. So this information I have to show here, right? If you see this perspective that I have shown right now here, yeah, this perspective. So this is looking like a square planar, right? This is looking like octahedral, fine, and this is taking proton from here. So all of the questions are answered in this picture, right? So I will take the picture of this. I can go here and I want to first label it, right? Because you don't know which are the elements. Just to mix. See, I can save the structure from here also. Just go to the file menu and save the images. And if you want to add the labeling, put the symbols here. These are not visible that much. Go to the view menu and the display format, and in the text size you increase from 18 to 24. Now it will be visible better, right? fine, and you can save this image. That is the good way. In go to the save images here, the for research publication, the TIFF quality is the best one, and PNG is also fine. So I generally suggest TIFF quality. And since we want background to be white, so I have selected white background here, and then you can save your molecule. Okay, so I will show you how it looks like. I will put in the screen, and I want to just level it, increase the size slightly more, 24. Now it is visible, and this palladium is looking octahedral, fine, and this is looking square planar. I will save this file. Okay, so background I've taken as white. So we can see this picture here. See the quality here, the quality of this picture. So for research paper publication purpose, you can use this quality, right? Now if you see every atom and whatever information that you want to present in this picture is exactly visible. So whenever you are presenting a picture, you should know what you want to present in that picture. You cannot give any perspective of your molecule. That is rubbish. Most of the time reviewer will be pointing out this problem. Okay, so this is the way to put your molecule, and these are the C1 symmetric molecules, so we are not considering the symmetry points here. But suppose the molecule which is having symmetries, C1 symmetry is not that so you can take any perspective that is better for your suiting for your molecule. But suppose your system is having C2, C2V, D2H, or whatever symmetry is there. So try to make at least suppose your molecule is having C2V symmetry. So try to make at least a molecule with sigma V plane and C2V. It looks. Suppose we are working for water molecule, okay, and you want to, or just assume, suppose. Okay, fine. So suppose you are designing this methane you are having here, and you have to put a picture. Okay, you can save this picture also, right? Suppose you want to use for your publication purpose, you can use this image. You can use any image, this image, anything. But that is not a good way, because it is having a tetrahedral symmetry. So it's the tetrahedral structure should be, it should look like a tetrahedral. So what I will suggest, take this image, right? This image gives a tetrahedral perspective for your system. So your point group symmetry, whenever there is a symmetry in your system, so make sure that symmetry is visible in your molecule. I can give like this also, right? But the perspective is, the molecule looks more like D3H rather than tetrahedral. Until you are very, you have to be very peculiar about the, atoms. Or you can give like this also. It looks like square planar. So these are misleading, geometries. So always try to give your molecule symmetry in a way that is, based on your symmetry point group. I can give methane like this also. I can use like this. I can put like this. I can put like this. But these are not the good way to present your molecule. The best way is this one. Suppose your molecule is ethane. You cannot put this way for your publication purpose. Right, you have to be in, suppose this ethane staggered form is most stable, so that staggered conformation should be visible whatever way you present that, but the staggered conformations will be visible. So if you are putting this picture for research purpose, for publication purpose, you should use this perspective where you can see the tetrahedral from the carbon side, sp3 hybridized tetrahedral, and their staggered conformation, and the dihedral angle between this hydrogen and hydrogen carbon carbon and hydrogen 180 degree. So those things are clearly visible here. So these are the best ways to present your molecule for research paper publication. Otherwise, see, you can put anything rubbish, but the way you are doing or working is kind of your signature thing also. So I suggest to use these ways to present your system molecules. If you have doubt anything related to this, put in the comment section. Thank you for watching the video.